Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today we are going to take an in-depth look at the in-order tree traversal technique, especially the practical side. And by practical I mean we are going to write a C++ program at the end of this tutorial to implement in-order tree traversal on our binary search tree. Now before we proceed, in case if you don't know what is a binary tree, what is a binary search tree, what are the different tree traversal techniques and the comparisons, we have already covered them in previous tutorials of this course of this playlist. So you can check out the complete DSA playlist. I'll link them in the video description or you can see a card. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Also, one last thing before you proceed with this tutorial is that I'm assuming you guys already know what is recursive function and the concept of recursion. If not, I have a separate video tutorial on recursion and recursive function with C++. Please make sure you watch that. That is very important, especially if you're a beginner. A lot of times students get confused in the concept of recursion. If you have the basic understanding, you're good to go. You'll understand this tutorial very well. But in case if you just dedicatedly want to see that separate recursive function topic, then you can check that video as well. Alright, enough of the introduction, let's get started. So as you can see on the top, we are talking about in-order tree traversal. Now in-order tree traversal is a type of DFS technique, that is depth first search technique, wherein you go searching into the different levels first. So you go deeper into the levels and not breadth wise. And the way you proceed is with the chronology of left, node and right. So that's why LNR. Now we've already talked about these steps, these theoretical steps as well as the working. So we'll directly jump to the pseudocode, which is nothing but the code representation of these English steps. Okay. So this is what our function is going to look like. Void print in order. This is the name of the function, and void means this function will not return anything because ultimately we want to write a C++ code, right? So for that, a pseudocode is much more easier to understand and much more easier to convert into proper code. And pseudocode is nothing but part English, part code kind of syntax, which does not follow strict standards. You can have your different syntax in pseudocode. Essentially, pseudocode is nothing but step-by-step, part code, part English way of writing the steps so that they can be easily converted into a proper code. Okay. So this is not a proper C++ code and this is not exactly proper English as well. It's a kind of a mix of both. Anyways, moving forward, this is going to be the name of our function, print in order, and it is going to take one node at a time. So you can see tree node. So tree node is nothing but this node. Now this node comprises of three sections. First, this is the name n1. This hash 31 is the address at which this node is created in yellow. This center element is nothing but the data, also known as key, also known as value. The left part is address to the left node or the left child. So hash 16 is nothing but the address of n2, you can see over here. And hash 99 is nothing but the address of n3, which is the right child. We've already discussed about this structure in depth previously, so I'm not going to waste time over here. But this is what is going to be accepted as an argument, as a parameter in this print in order function. Then we have 4 steps. Now if you see these English steps, we have 1, 2 and 3 steps. That is because we have one extra step in the pseudocode because we want our program to stop at a particular point, right? When you are traversing throughout this entire tree, there will be a time where you'll have to stop the execution. And that's why we have this extra step, which is the stopping condition. So the first step goes as follows. If r equals to null, then return. So when you pass a null value as a parameter in this function, we will stop the execution. Okay. So that is something that is not mentioned over here because this is just English and this is the actual practical side. Then the step 2 is print in order r of left. So now you can see we are giving a recursive call which corresponds to step 1, which says traverse the left subtree by recursively calling in order function. So this is a recursive call, which means it is calling itself. You can see the name print in order and print in order. So we are calling print in order from print in order, which kind of sounds like Inception, but yeah, that's how it goes. And this time the node that we are passing is r of left. So if R is going to be N1, which is basically this root node, R of left is going to be the node which is to the left of N1, that is the left child. So hash 16, which is N2. So over here you'll pass N2. Then this again print, then again this print in order will start from the beginning. And again you'll start from the very beginning of the function, and that's how the recursion will progress. Don't worry, this might sound a little confusing right now, but I will explain to you step by step. We will dry run this entire print in order function onto our existing example. So let's go ahead and dry run this entire function onto our given example. So the example tree over here is a binary search tree. It is not a regular binary tree. Now binary tree and binary search tree are structurally pretty much the same, but the only difference in a binary search tree is that it follows the principle where for every node, the left child or the left subtree has smaller values compared to that node. So for N1, this is the entire left subtree and it has values 18, 10 and 25. All of them are smaller than 30. Similarly for node N2, what is the left subtree? This is the left subtree. It has value 10, which is less than 18. And this is the right subtree. It has value 25, which is greater than 18. Okay. So that is the only difference. Otherwise, structurally, binary tree and binary search tree are pretty much the same. So all these different traversal techniques, that is all the depth first traversal techniques, in order, pre-order, post-order, all of them are going to be exactly the same on both binary tree and binary search tree. We are taking the example of binary search tree because ultimately we are going to write a code to implement this for a binary search tree. Okay. Hence that's why we have this example. And this was the same example that we took previously. So if you watch the pre-order technique video tutorial, then you can also compare the outputs. It's going to be different. Alright, so anyways, let's start off with the execution of in order function, that is this print in order. So for the very first time, let's see what is the function call. So when you call this print in order in your main function, it would look something like this. Okay, so for the first time, you call print in order and you pass N1 because N1 is the root and tree traversal will always start from the root and then you go to the deeper levels. Okay. So when you pass N1, this R will become N1, right? Okay. So let's go with step number 1. Step number 1 says if R equals to null, then return. Is R null? No. R is currently pointing to N1. So N1 is not null. Obviously N1 is an object which is created in the memory at address hash 31. So of course R is not null, which means the first step will not be executed. You will not come outside this function. Then you'll progress to step 2. Now this is where a recursive call to print in order is given and you're saying print in order R of left. R is currently pointing to N1. R of left means the left child address, which is hash 16, which is N2. So now we are going to pass N2 over here and we are going to give a recursive call to a print in order function. So second print in order function is called. So basically what happened is first print in order, this function is calling second print in order. Okay. And when this happens, this is a recursive call. We are passing N2. You can see N2 is passed as an argument. That's what I explained over here. So first print in order function called second print in order at step 2, right? We were at step 2. So now since another function is called, this first function will go in a pause state. So that's how recursion works. So I'll do a pause symbol over here and it got paused at step number 2, right? Because this is where it gave a recursive call. So let's write 2 over here, which represents step number 2. Because the first print in order got paused at step number 2, it still has to perform step number 3 and step number 4. Only after performing step number 3 and step number 4 will the complete execution of this function be over. But because it got paused at step number 2 and called itself, that is, it called another print in order, it got paused at this step, and now this second print in order will start its execution. So that's how recursion works. So let's again perform print in order on N2. So performing print in order for N2, this time N2 is passed as argument. So R is going to be N2. Again, step number 1, if R equal to null, then return. No, R is not null, R is pointing to N2 now. So first step will not be executed, we will move to step 2. As soon as we move to step 2, again, a third print in order is called, another recursive call, and again we are saying R of left. R is currently pointing to N2. what is there to the left of n2, that is the left child of n2, it is #6, which is n4. So now we are passing n4 over here. Now as soon as a third call is given, that is this function, you can see third, as soon as a third function call is given from the second function call at step number 2, this print in order will get paused because it is calling third print in order. So let's do a pause symbol for second print in order, and it got paused at step number 2 because that is where it called one more print in order, which is the third print in order, right? And this time we passed n4 as the parameter. Okay, let's again start executing third print in order. So for third print in order, again r value is n4, so r is nothing but n4. So step number 1 is, if r equals to null, then return. R is not null, r is pointing to n4. The reason why I'm saying pointing is because in C++ we are going to use the concept of pointers. So these are nothing but pointers that we are playing with. Anyways, first step is not true, so it will not be executed. We will move to step 2. Now again a recursive call is given. A fourth print in order is called. We are saying r of left. Okay, so this time what happens is, if you observe, r is currently pointing to n4. So r is pointing over here. What is there to the left of n4? That is the left child of n4. We don't have anything. We have null over here. So programmatically we will have null inside this. So now we will pass null over here as the value. Let me use another color. So this time at step number 2, for the third print in order, we are gonna pass null for the fourth print in order. So you can see a fourth print in order function is called, but the value that is passed is null over here. So third print in order will call fourth print in order, and as soon as it calls fourth print in order, it will get paused at step number 2 because that's where it gave that call. So step number 2, it is paused. Let me do a pause symbol again. And now a fourth print in order function is called. So let's see how that goes. So this time for the fourth print in order, we are passing null. So r this time is nothing but null. Now as soon as we go to step number 1, we check is r equal to null, and this time it becomes true because we've just passed null as the argument. So this becomes true. That is, the first step becomes true, and we say then return. So when I say return, it means that you simply do not continue this function. You do not execute step 2, 3 and 4. You completely come back or come outside this function. So when I say return, it means that this function is done or it's completed its execution and you come outside this function. Okay, so at step number 1 itself, we are saying return. When I say return, you come back from fourth print in order to third print in order. Now why does that happen? Because fourth print in order was called by third print in order. You can see the arrow. So when this function is done with its execution, when we are returning back, it will also come back to the calling function. So when this happens, when the fourth print in order function is completed and it comes back to third print in order is in pause state, and now since fourth print in order comes back to third print in order, it will resume its operation. It will resume its functioning. So I hope you're getting this. It's a little complicated, but if you've seen the recursive function tutorial, I'm guessing it would be much more easier to understand. But anyways, let's continue. Now that fourth print in order has come back to third print in order, this third print in order that was paused at step number 2 will resume from step number 3 because step number 2 is done for third print in order, right? So now we will go directly to third step. Now third step states that print r of value. Okay, so for third step, what is the argument or what is the node that we are passing? It is n4. So n4 is the node that we are passing at this print in order. So when we say print r of value, we are saying n4's value, right? What is the value or data or key inside n4? We can see that it is 10, right? This is the value. So now we will print 10 over here. Okay, so I'm gonna write 10 over here. So now that we've printed n4's value, that is step number 3 is done, we will then proceed to step number 4. So now step number 4 is print in order r of right. Okay, so again we are calling print in order, but this time it's a recursive call wherein we are passing the right child as the argument. Again, r is n4, who's there to the right of n4? So n4 is this node. Is there anything to the right of n4? No, which means we are gonna pass null again. Correct? So a fifth print in order function is called from third print in order, because we were at third print in order, and third print in order function just called fifth print in order function, and we've passed null over here at step 4 for the third print in order. So third print in order function will again get paused at step number 4, because that's the last step wherein you give one more recursive call, and the recursive call print in order we are passing null. So for this print in order, when you pass null as r value, so r is passed as null, the first step itself we check r equals to null, then return, and this is going to be true, so we will not proceed further. So we will directly come back from fifth print in order to the calling function, and I just mentioned that third print in order function called fifth print in order function, right? So we came back. Once we come back, this third print in order function will resume its operation from step number 4. Step number 4 is done. So now it's gonna resume, and if you observe, we only have 4 steps. So when this print in order function is resuming from 4th step, which means it is done with the 4th step, of course all the steps are done, which means this third print in order is completed its execution, so it will go back to the calling function. Because of course third print in order was also called by some other function, which is this second print in order. So now it will go back to second print in order. Okay? So I hope you are understanding how this traversal is happening in a recursive way, step by step. And now let's continue with the second print in order, which was paused at step number 2. You can see I've written 2 over here and a pause symbol, which means our second print in order with the r value of n2 was paused at step 2. So once third print in order returns back to second print in order, it will resume its operation from step 3. Now in step 3 we have nothing but print r of value. What is the r value at this second level? It is n2. R is pointing to n2 in this function, right? So when I say r of value, it means n2's value. What is there inside n2 as the value? It is 18. So now 18 is going to be printed. So I'll write 18 over here. Then step 3 is done. And then I'll move forward with the step 4. Step 4 again I'm saying print in order, but this time I'm saying r of right. R is currently pointing to n2. That's what I wrote over here. So n2's right is nothing but an address #26, and #26 is the address of n5. So I'm passing n5 over here. So a sixth print in order function is called. So this is the sixth print in order function from second print in order. So this is how the direction goes. And then second print in order again goes in a pause state at step 4. So this is where it got paused, right? So let's do a pause sign for second print in order, and it got paused at step 4. Okay. Now the sixth print in order we've passed n5 because that is to the right of n2. So let's execute print in order for n5. Okay, so now r is n5 for this sixth print in order. We check r equals to null. R is not null because r is n5. So it's not null, of course. So this step is done. We move forward. We say print in order r of left. R is n5. To the left and right of n5 we don't have nothing. We have null. So at step 2 of sixth print in order, we say print in order r of left, which means we are passing null. But one more print in order function is called, which is the seventh call. So sixth print in order gave a call to seventh print in order, passing null in it. And when we pass null, of course we know that what happens at step number 1 itself, we come back. So when sixth print in order function gave a call to seventh print in order at step 2, it was paused at step 2. Seventh print in order function accepted null, and at the very first step itself it came back. So it will come back from seventh print in order to back to its calling function, which is sixth print in order. So now sixth print in order will resume its operation again from step 3. So for step 3 we have print r of value. At the level of sixth print in order we have n5. So r is nothing but n5. R of value means n5 of value, which is 25. So I'm gonna write 25 over here. So it's gonna get printed. Basically means we are accessing it. So accessing and printing is pretty much the same. When you want to print the value, you have to access it. correct? So for 6th print in order, step number 3 is done. Now we move to step 4, which is another recursive print in order call, but this time we say r of right. R is nothing but n5, so n5's right is nothing but null. So 8th print in order function is called from 6th print in order, and the value being passed is null. So again 6th print in order will get paused at step 4, correct? Because this is where it got paused and we called a print in order, we passed r of right, which is null. As soon as you pass null in this call, at the very first step we check if r equals to null, then return. So we will come back without any further processing. So from 8th print in order we will again come back to the calling function, which is 6th print in order. Now once we come back, the 6th print in order function will resume its operation after step 4. So now it is in resume state, and after step 4 we don't have any further steps, which means that the 6th print in order has completed all the steps. So it will go back to its calling function. Who called 6th print in order? You can see the arrow. Print in order number 2 had given a call to 6th print in order, so we will go back to that. Once we return from 6th print in order back to 2nd print in order, you can see that this second function call was also paused at step 4. So once it gets resumed, it will also have nothing else to further process because we only have 4 steps, which means that the 2nd print in order is also done. So it will also go back to its calling function. Who had called the 2nd print in order? The 1st print in order. So we will go back, and now the 1st print in order will resume its operation from step 3 because it was paused at step 2. You can see over here. Alright. So now the 1st print in order will continue its execution from step 3. What is the step 3 for the 1st print in order with r of n1? It is print r of value. So r at 1st print in order call is n1. n1's value is 30. So now I'm gonna print 30. Okay. Alright, step 3 is done for 1st print in order. Now moving on to the last step for the 1st print in order, which is another recursive call to print in order, and this time we are passing r of right. R is n1. So r is root node. What is there to the right of n1? It is hash 99, which is nothing but address of n3, which means we have to pass n3 over here. So now this 1st print in order will get paused at step number 4, which is this step, correct? And it will call the 9th print in order function, which is of course a recursive call. So this is how it would look like, the 9th print in order function, and this time we are passing n3, which is to the right of n1, which is the right child of n1, right? Okay. So this is paused. Now we will start executing with the 9th print in order. So for 9th print in order, let's start from first step. R is nothing but n3. We check if r equals to null, then return. R is n3, which is not null, so first step will not be executed. Step number 2, we say print in order r of left. So another recursive call is given, and this time we are saying r of left. Who's there to the left of n3? Because currently you can see r is pointing to n3. So r is over here. Is there anything to the left of n3? No, we don't have a left child for n3. So that would mean that we will pass null, correct? So 9th print in order will get paused at step number 2, and it will give a call to 10th print in order, and it will pass the value of null. Now as soon as you pass the value of null, we know what happens at the very first step itself. We check r equals to null and we come back, and when I say come back, the 10th print in order will do nothing but come back again to the calling function. 9th print in order was the calling function, so we come back. Okay. Now as soon as we come back, the 9th print in order will resume its operation from step 3 because it got paused at step 2. Step 2 is done. So then we move to step 3. Step 3 is print r of value. For 9th print in order, r is n3. n3's value is 45. So now we will print 45. Okay. Alright. So once step 3 is done, we move to step 4, which is another print in order function call. But this time we are saying r of right. R is pointing to n3. Who's there to the right of n3? It is n6 because hash 83 is the address of n6. You can see over here. So now we are passing N6 and a 11th call is given from 9th print in order, and 9th print in order gets paused at step 4 because that is the last step it got paused at. So now we have to execute print in order, which is the 11th print in order call for N6. So let's get started. So R is now pointing to N6. We say if R equals to null, no, R is pointing to N6, so it is not null. So this step will not be executed. We will move to step 1. We say print in order R of left. Is there anything to the left of N6? No, it is blank. So a 12th in order function will be called from 11th print in order, which means 11th print in order will get paused at step number 2. I'll write over here, and it is calling 12th print in order, and we are passing null. As R of left is null, there is nothing to the left child of N6. So as soon as we pass null at the very first step of the 12th print in order, we will check if R equals to null. If yes, then return. So we will directly come back. So we'll come back from 12th print in order to 11th print in order because 11th was the one to call the 12th one. Now again 11th will resume its operation from step 3 because step 2 is done. Step 3 is print R of value. R is pointing to N6. You can see over here, value of N6 is nothing but 65. So we'll print 65. Step 3 is done. Now we will call step 4, which is another recursive call. We'll say R of right. R is pointing to N6. We don't have anything to the right, which means that the 13th call is going to be a call which again takes the argument of null. So you can see 11th print in order is calling 13th print in order. 11th print in order gets paused at step number 4 this time because that's the last step. As soon as you pass null in this 13th print in order and you start executing this 13th print in order, the first step itself says R equals to null, then return. So we do nothing but simply come back. When you come back from 13th print in order to 11th print in order, this 11th print in order will resume its operation from step 4, that is step 4 is done, and we don't have anything else to execute in the 11th print in order because we only had 14 steps. So even this 11th print in order will go back to its calling function. Who had called 11th print in order? The 9th print in order. You can see the arrow. When you come back from 11th to 9th call, even the 9th print in order was paused at step 4. You can see over here. So it will resume its operation after step 4. And we don't have anything after step 4. We only have 4 steps, which means even 9th print in order will return back to its calling function. Who had called 9th print in order? It was the first print in order. You can follow this arrow. Even the first print in order was paused at step 4. So when 9th print in order will return back to first print in order, it will resume its operation. And when I say resume, it will basically have completed all the 4 steps. And ultimately you will come back in the main function. And as you can see, we have got the complete output of 10, 18, 25, 30, 45, 65. And that is how the in order values are printed. Now if you've watched the previous tutorials, you can compare those in order output with this output. It will properly match it. And we have successfully dry run the entire pseudocode for in order traversal of a binary tree or a binary search tree. Okay, so now let's quickly switch to the Dev C++ IDE and convert this pseudocode into a program because ultimately we also want to see the practical side and not just theory and not just working. So let's quickly switch to the programming side. Okay, so I have my Dev C++ IDE open and you can see we've already typed in quite a lot of code. We've created the tree node class. We have also started with our BST class. In fact, we've written the isEmpty function. We've written the insert operation. And we had this extra 2D function for printing. We will talk about this later. In the previous tutorial, we also did the print pre-order. And now just below this, we will do the print in order function. Now I'm just copy pasting this code. That is because we only have 4 steps and you can easily type this. Just pause the screen and type it along. I am going to share this entire BST operations code with you. So you can find a link in the video description. If it's not available yet, it will be soon once we complete all these topics on the BST operation. So yeah, just comparing the print pre-order and print in order. The only difference being is the order. So in print in order, we were first printing the value. In print in order, we are first traversing to the leftmost side and then printing the value. So that's the only difference, but the output completely changes. Hence we say root left right, and here we say left root right. Root can be also termed as current node, so I'll write current node over here. Okay, so yeah, this is the code. I hope you already know the syntax. We've started with the implementation of binary search tree long back, so I'm guessing you guys already know. Scrolling down to the main function, we have made a menu driven program which takes in node values and inserts it into the tree, and then we can perform different operations. We have done with the insert. We are currently on the printing and traversal. So when you want to print, obviously you have to traverse the entire tree. So this is print / traversal. So in option 4, in the switch case 4, this is where we are printing. We've done with the 2D printing, we've done with the pre-order printing. I'm just gonna copy this, hit enter, paste, and we are saying print in order. Okay, so I'm printing both the values so that we can compare. Here I'll just say cout endl to come on the new line, and even after this I'll do that. Okay, alright, let's save this. Let's go to execute, compile and run. This should work. Okay, so our program is working fine. Let's enter all the same values that we just dry run on the digital blackboard. So first, option number 1 for insert. So first we have 30, value inserted as the root node. Again, option number 1 for insert, we have 18, hit enter, value inserted to the left. Again, option number 1 for insert, we have 45, hit enter, value inserted to the right. Again, option number 1, enter the value of tree node to insert. Option number 10, value inserted to the left. Again, option number 1 for insert, we have 25. Again, option number 1 for insert, we have 65. Okay, so these are all the values that we've inserted, and these are the same values that we were dry running for our BST code. We can do the clear screen. Option 5 will clear the entire screen. And now we'll do option number 4, which is for printing and traversing. So when I hit enter, there you go, the first printing is for that 2D printing. This is the binary tree with 30 being the root node. So the tree is pretty much rotated in a anti-clockwise 90 degrees, but that is the best way you can represent it on a command prompt in a structural way. So 30 is the root node, left child is 18, 45 is the right child. For 18, left child is 10, 25 is the right child, and for 45 we do not have a left child, we have a right child, which is 65. Now this pretty much resembles exactly the same like what we have onto our digital blackboard. So you can see over here 30, 18, 45, 10, 25, 65, that is the exact tree over here. The output over here is, for the first we are saying 30, 18, 10, 25, 45, 65. This is for pre-order, and the second one is for in order. I should have specified that over here in the code also, but anyways you should understand this, because of course first we are calling pre-order, so the first line is the pre-order. We are not interested in that. Just observe this second output, 10, 18, 25, 30, 45, 65, and if you compare it with our output, it is exactly the same, 10, 18, 25, 30, 45, 65. So 10, 18, 25, 30, 45, 65, which is exactly matching, which means our pseudocode and our dry running was perfect. Our program also ran accordingly, and we have successfully implemented the in order DFS tree traversal technique. Okay, so this is all for this video. I hope you understood this video. Please give this video a like. Let me know in the comments how this video was. Do share it with your friends. It takes a lot of efforts to create all these graphical representations, visual representations. So like, comment and share is highly appreciated. In the next tutorial we will take a look at the post order technique, and I'm gonna wrap this video over here. Thanks for watching. See you in the next one. Peace.